You won't find it here. So it's like it's a we're doing the September 24th slides here, which is actually a continuation of what we started last Tuesday. And on Tuesday, we began with looking at the coronavirus analysis code. So please look at that code and kind of use that code for your own research here. And what I mean by that is that much of the data that you'll find that comes through online on sites like Kaggle and some other sites, even if you go to the World Bank, for instance, you can download economical data, and it just comes in giant spreadsheets. And this spreadsheet data can be wrangled and seemingly hacked just exactly the same way that your coronavirus code does that. And so, yeah, hang on to that code though. I mean, you still use it to explore the data from coronavirus, but look at the code itself though, and you can use that to explore other kinds of data. And I think you'll find that it might take some of the heartache out of actually working with the analysis, or the wrangling or the plotting, because you just have to readapt the code. Anyway, so I wanted to take you through these slides here. I think these slides are actually quite interesting. The slides that we have, or hopefully you can see everything on screen. Here we are. We were talking about using data to answer a question. We ran this code right here. Let me just go ahead and get started with showing you how this code works again, because I think that perhaps, well, it's been a while since we've seen this. But this over here is your, if you can see this, this library tidyverse. That is the library that's going to be giving your RStudio extra functionality. And what I mean by that is that it allows your RStudio to plot things. It uses that Ggplot. That's where Ggplot, in this case, comes from. Now, you need to have these libraries installed to run Ggplot. And the reason why, at a coding level, the reason why they have libraries in R, or I guess any programming language at all, is because if you didn't do that, then the programming languages would just be so huge. I mean, you'd have so many things to install to run your code, and they try to reduce that. They basically there's a core set of the language that you need to do basic math and statistics. But if you want to do anything more than that, then you have to install these libraries. But also the libraries are important because you might find that there are specific libraries that are dedicated just to the analysis of, say, coronavirus data, or data that's from online, or maybe there's a library that helps you to pull over specific data sets in real time from some from I don't know, some OECD or the European Economic Community data source. So you can actually find libraries that handshake with data sources and then pull over in real time data, and that's all possible through these libraries. And so this is extra code that you can use for your system, or for your RStudio here, which will allow you to do some really quite extraordinary things. Now, I'm going to go ahead and just put this code back into RStudio just to show you how to what it looks like when it runs here. I'm just going to select everything. I know this is probably quite dangerous to do, because if I do that, then I'm going to lose my formatting. But go ahead and start up your RStudio. And when you've started up your RStudio, you should see something that looks like this. Hang on a second here. I'm going to open up a new file, RScript, and I'm going to just paste all my stuff in, all the code that I've just gotten. And this is a text editor, in other words. You can use this to edit text. And so what I'm doing here is that I'm going back. I'm going to obviously have to go back to the slides here and make sure that my code is, everything's on the right line. That's one thing that's actually quite annoying about copy and pasting. But actually, though, it seems like it works okay. But I'm just going to go through and put my code in where it's supposed to be, and this should actually do or get the result that I'm looking for. Let me go ahead and put I'm going to save this, by the way. I do that, as you remember, because if anything happens to if my computer shuts down or something crashes or whatever may happen when I'm working on this, I don't lose my code. In fact, I can just run all the code that I've been using up until this point. So now you can't see what I'm doing, but I'm actually saving this. I'll just put this down as, I'm saving this as 24 September notes, and then I'm just putting this file someplace safe where I can get to it. Okay, good. So now remember that when you run this library, you put the cursor on that line, and then you can't see what I'm doing here, but you can click on the Run button, and the Run button will then run your library, or actually load the library. It doesn't run anything, but it loads the library so that it's there. And that's what you see at the bottom of the screen there. I'm going to move this over just a tad so that it doesn't look so hard to. Hang on a second, I just have to move it out of the view for just a moment. I'm going to just slightly slide this over and down. Voila! And now you should be able to see. Excuse me. Now, if I go back to right there. Now, if I go back to my code that I'm looking with up here, remember, I'm putting all my code up at the top here so that I can get it. So if anything terrible happens where I lose something, it's not gone. But the thing is that we have this command here called view MPG. Now, MPG is the data set we're working with. Much of the data that we get online, or sorry, with these, when we get a library, for instance, many of the libraries actually come with their own data so that we can play with this code and kind of get an idea about how to use it. And so some of the data that comes with tidyverse is this code, or this data set called MPG, or miles per gallon, just what they call it. And miles per gallon, as we remember, is different cars, different sizes of car, different types of car, different car years that they were when they were created here, when they were built or designed, I guess. We have, we type in this command. Tell you what, let me get this a bit bigger so you can see. Hopefully that helps. Maybe that helps. Maybe that helps. So when you look at the data set, you want to sort of, when you first do some kind of analysis here, you always want to spend special time looking at the data. Remember, because the data is going to inform you about what kinds of questions you can ask. So here we are, the manufacturer, the model. We have the displacement. The displacement is a metric of how much energy it takes to move the car. So heavier cars have a bigger number. So this, I'm looking at this line right here where we have Audi A4 3.1 2008. Because I have this 3.1 number, this suggests to me, just by the data, that the displacement for the A4, see it says it's 3.1, it's a heavier car than the Audi A4 from 1999, which has a displacement of 2.8. Now, they're both kind of heavy cars, but they're nothing near as heavy as the car as the A4 that came out. I'm looking at this car up here, displacement of 1.8, which is an auto, what is it, i5? I don't know what that kind of car is, but it's a lighter car. So the displacement is an indication of how much energy it takes to actually get that car moving. You can think of it as in terms of like energy that you have to expel to actually move the car through. So you're looking at that, you have the year, then you have the CYL, which is going to be the number of cylinders. Now cylinders is the size of the engine. And so that's another metric that you can use to measure like maybe the size of the energy or the amount of fuel that it would probably end up guzzling. So more like the bigger the car, the more cylinders you need to turn the engine or to actually get the car moving. Then we have the drive. This is the front wheel or rear wheel drive. You can see that we have a number 4 here. That means that it's a 4-wheel drive. And then we have the city and highway, CTY and HWY. That's the mileage. How many miles per gallon do you get when you're going through the city, and how many miles per gallon do you get when you're going through the highway? Now, one question I will that I got last semester when I taught this course is why is there a difference between these two numbers, a city mileage and a highway mileage? And that is because if you think about driving in the city, you have to continually brake and stop at stoplights and at walkways and things, and so the car has to stop and then it has to then start moving again. And that actually, when you have a car that's at rest and then you start moving that car forward, that uses up a lot of power or a lot of energy here. But when you're on the highway here, the car is just coasting, and so you only really have to, it's in terms of like startup energy, you don't have that much startup energy to spend on the highway because the car just starts and then it goes for miles and miles and then it stops. Whereas in the city, it starts and stops, then starts and stops and starts and stops. And so that's, each time you start the car moving, that's going to be burning up extra fuel. And so that's why there's a difference between these two numbers. But in terms of our data, we should care about those numbers because if we live in the city, as I'm thinking that many of us do, then that number might be especially important to us as we're figuring out whether this car is going to be economical for us to drive. I mean, if you're driving the city, then that's the kind of fuel that you're going to be looking at spending. The FL, the fluid, I think it is. I'm not exactly sure what they mean by the P here. It seems like it's PRE. It must have some reason, some meaning to people who are car buffs, but for me, I'm not really a car buff, so I don't really know what that FL has to do. But that's a different type of data entirely. It's not numerical. It's well, we'll talk about this, but it's an ordered type of data. And then we have the class, which is a type of car here. So this is the compact class of car. I'm moving down here. I can see SUVs, two-seaters, mid-size. And so really you have all minivans, you have all the kinds of cars that you think about buying here. So this data, going back to our slides, this data is actually quite important because remember that we're asking the question here is the main question that we're asking our data, which can really realistically be answered by this data. What kinds of classes of cars get the best city mileage and the highway mileage? Now, when you do an analysis project like this, it's handy having plenty of data, as we see here. You want to have as much data as you possibly can to get your analysis, because if you only compare two cars, let's say you have your car, and then your brother has a pickup, and then you ask your brother how things do and how he does for his mileage, and then your sister has a compact car, and you ask her, and then you may ask some other people. That's really only one data point, and while that's informative, it doesn't really give you a full story. But if you have like a whole bunch of data, as we see in this particular case here, where you have all these different types of cars and everything, then you're actually able to investigate the patterns of the data. And that's really what this class is all about, is not just asking a question and using one point to answer it, but actually using a whole multitude of points and a whole bunch of different pieces of information to answer questions. So that is actually quite a big thing here. Let me just move on to the, let me get back to my slides here. Where's my window? There we go. So let's go back to the thing here. So what we did is we're using this, let's go back to our code. That's what I'm going to do. Let's go run the code. I didn't run the code. Goodness gracious, what is going on here? So going back to this code that I have in my notes here, here we are. So I'm going to run this library here, and by doing this, I just put my cursor on the line there, I hit the run, and then I hit the view, I can view the data, which we've just done, and then I have over here the actual plotting here. Oh, you know what, I need to, this is leftover stuff from the comments, but this should be able to work. There we go. So this is my plot. But one thing that we discussed last Tuesday, was that this is, while it's informative, we could make it much more informative. We could actually get more information out of this. And what do I mean by this? Well, if you go back to the data itself here, the MPG, you'll notice that we have many different columns of information here, all of them. And so we could use these columns in other ways to answer the question. We could actually apply some of this information into these columns. Now, yes, looking at the plot here, we do have each point here is represented by an X and a Y point. But one thing we discussed, though, is that you could actually incorporate more types of information into our plot so that we can get some maybe color, we can get some sizes, we can get some other things, and kind of have a better look at what's going on in the data. So let's go back to the slides here, and I think that we've actually done something here where we can see that. This is, for your information, this is actually quite handy. I'm hoping you'll use this as a kind of a cheat sheet, by the way, that when you're using this plot, you'll have this this cheat sheet, I guess, where you can just basically work out how to use the code to plot your data. The Ggplot function is going to be working exactly the same way. It seems that every time you use Ggplot to plot anything, you're going to have a function that looks very similar to this. So you have, and then I wrote down here what each piece is actually doing. This is the graph that we have. Then one thing we changed is we said, okay, well, is there anything more that we can add to this graph? And then we just changed it to blue. But one point that we discussed was that just changing the points to blue is not informative. Yes, we added some color, but it doesn't actually give us any more information. It could be red or pink or blue or green or any color you want. It doesn't actually give us any more information. So then if we tried adding some information about size, here's this other piece of information. Here's the class. That's another part of our data that we have here, class. In fact, we can see what that looks like. Class is right down here. You can see that, where's the class? Class is at the very, very end. And so this might be informative to us because now in our data, we can figure out whether we want to do, if we want to buy a car that's a minivan, or whether we want to buy a car that's a mid-size or whatever it may be. We can look at different, we're not just looking at the miles per gallon anymore, the displacement on the highway, but actually we're looking at individual cars that make that displacement. So I like this function here. Let me just go ahead and put this out here so I can marvel at this thing all over again. I'm going to go back to R, and I'll go back to my notes, which is right here. I'm going to dump this in. Now, hopefully it's going to just run without me having to go through and edit anything. But you can see now that you have on the in the legend, you have class information. Now that's important because now you have not just x and y coordinates of the miles per gallon or the displacement as x and then the miles per gallon on the highway as y, but actually though you have more information coming to you that is in the form of what kind of car was it that actually produced that mileage. So that's cool. Now going back here, we can actually now add some more information here. We can get some more. Maybe we could use color. One of the problems. Let me just take you back to this other thing here. One of the problems with the sizing though is that it's very misleading because after a while when you're staring at this thing here, can you really discern the size between, I would say, looking at mid-size and minivan? When you see a whole bunch of points together, look at the miles per gallon area just above between 5 and 6, maybe 5.4, where x is equal to 5.4 and y is equal to, I think, maybe 15. There's a clump, and you can't really see the sizes of things very easily. In fact, if you have more and more points, then eventually everything just becomes kind of just blocked off, and so you can't see anything. And so then you might consider using color. You might consider having the points maintain a uniform size where everything is small, but then you find that, for instance, you could change the class of the cars using different types of colors. One thing I will say about color is, while I like color, 1 in 8 men is colorblind. That means they can't see the red-green. They can't see the difference between red and green. And so if you're throwing out colors into your plots, be sensitive to that, because not everybody will be able to see a plot where you say, now look at the green points, now look at the red points, now don't you see any difference? Because to them, it all looks maroon. They won't be able to see anything. And so be sensitive to that. And so you might avoid using green and red on the same plot. And I try and do that. But in this case, I haven't. I just let it go. But I do try to avoid using colors. You might notice other types of colors that might look similar. For instance, I'm looking at minivan and midsize and pickup. And when you're looking at these points from far away, if you're using a projector, for instance, that doesn't have very good light intensity, then it can again be difficult to differentiate between the two different colors. So do be sensitive to that. But another thing you could try though is that if you'd like to kind of have you could add more. You can still use color here, but I think that when you use color and size, then it adds a little extra knowledge. So here we have the cylinder is the size, and you can see that I'm just adding this code to the bottom here. I'm just adding this piece of code here. I have this is my aesthetics function here. It figures out where the points are going to go on the canvas. So that's my x point, and this is my y point. But then in addition to where the points are actually going, it determines how to decorate them using these parameters here. And so one parameter which is built in is called color. And class, what is that word? Class, remember, is the, where's my data? Where is my data? Did I just close it? Oh, here it is. The class is this column of information on the right-hand side. And so that's that. That's all it is. And then going back to the code here, you see that the size is another built-in parameter that's built into the aesthetics function here. You don't change that word. That word stays there. But this other word here equals cylinder. Cylinder is also in our data set here. You can see it right here. Right, so what I'm saying is that when you combine the color, the size, and perhaps some other things to your plots, they become actually much more useful. And one of the things that I'm concerned about, though, is that you might be creating some plots that look, just beautiful, just really wonderful looking plots here. But you need to ask yourself, is there anything that can be learned from these points? Is there anything that can I learn anything from these points? Is there anything that's actually am I getting any information out of this that I didn't already have for the more simplistic graph? Now, this is the time when you want to actually do some comparing here. So we are looking to see whether the highway mileage and the city mileage has some common commonality to it, some common trend to it. And yes, it does. We can see, let me just go back to this up here. This is the highway. You can see that there's the plots start at the upper left and they make their way down to the lower right. And so that means that as the displacement increases, in fact, you can't really see it, but just above where I am right now, on the x-axis, as the displacement increases, in other words, as the cars cost more energy to move, you get less and less mileage on the highway. And you can see also from this point that, or from this plot here, that as the displacement increases, in other words, as the cars get heavier, you need more cylinders in the engine to get that car moving. And also, going by the colors of the class, I can see that, let's see, pink and blue and orange, it looks like SUVs, subcompacts, and pickups are the heavier cars. So that's for the highway. Now, supposing I wanted to run the same kind of analysis and compare the city and highway. Now, you can see from these two different plots here, you can put the code in there and actually look at these, but I like to have them on the same page here so I can see them both together. You can see that these points, and this is a boring graph here, there's no color and no sizing, but we could add that. But you can see though that there is a common trend, and that is that cars that tend to do poorly on the highway tend to do poorly in the city too, and we expect to find that. But I mean, honestly, by the nature of data analytics, we can't just say that that it's true that city mileage and highway mileage are the same. We have to go in and actually think about the reasons for why these numbers would be the same. Here, I think we can all come up with very obvious reasons about why the mileage in city and the mileage in highway appear to be the same. But in other types of analyses where you're looking at two comparative plots, you'll find that there's two plots that are similar, and you might think, oh, well, the reason why they're similar must be the same. But it may not be that case. And so don't jump to any conclusions here. Always take your time and look at these things and then consider how you would explain the highway mileage in one thing or the other one, or the other plot here, and then determine, could there be some kind of a link? Could they be skewed in the same way for the same reason? And sometimes they're just skewed in the same reason, but that's completely random. It doesn't mean that they're not actually connected in some way here. In this case, we can kind of get the idea that they are, because we can explain where this data comes from. But if you're looking at data that has nothing that you don't understand, then it's very hard to make that connection. Now, this is how you put two different plots together on the same canvas here. It just gets messy from here on out, so bear with me, everybody, please. This is the first plot, Ggplot data. Then we have this geom point here. This is the establishment of the canvas, and then we say, okay, what am I putting in my canvas? I'm going to map points to this canvas, and this will come from the aesthetic function. So that's the first canvas. Now we're doing the same thing with the other, with the other function here. The other function is using the same canvas. So it's one canvas with two functions that are plotting there. So let's see here. We have, in this case, the red. My x is equal to displacement. In fact, they're both x's have to be equal to the same thing here, so they're both equal to displacement. But the red case here, the y is equal to the city. That's the city miles per gallon. And the blue, my y is equal to highway. Does everyone see that? And so it just gets kind of cluttered from here on out, but you can actually put together many different types of plots in the same way. Let me just go ahead and show you. Let me get back to my RStudio, and I'll put this in my notes. There we go. I'm going to run this thing. I get, for the data, I'm looking at blue and red points, and the blue points, in this case, correlate to my highway, and my red points correlate to my city. And so you can see, when you have both plots together like this, that there really is some kind of common feature. There's a common, a common trend that exists between both of these data sets. And this is what data analytics is all about. It's finding that common feature. It's finding that comparison. So you take two different plots here, and you find out that they're actually quite similar. And so you actually, one of the things here is we've been using plots to do this. We haven't actually been pouring through the numbers. I mean, we have numbers. But if you give someone numbers like this and say, oh my gosh, you should check out these numbers, the the trends are outrageous, they're not going to see them. You have to do something like this. You have to make something visual, because we're very, very good as people at picking out trends in graphical data. And so a lot of this class, excuse me, a lot of this class is actually about is about determining these trends using a visual means. And so you'll notice that a lot of data analytics discussions and articles and papers, and in this class, there are charts and plots and histograms and pie charts, and there's graphics everywhere, because you really need something like that. I mean, here we have not a very big data set, but if you have like a data set where you're asking maybe everybody on Earth what they're thinking about or what their interests are, and you somehow take all that information and you put it into some kind of into a plot, how are you going to I mean, how else could you show them, or could you describe all that data? And so as data gets bigger and bigger, there's more and more reliance on actual visuals. Now, going back to our plots where we're making this comparison, remember how we had before the cycle or the cylinders of the cars? We can add some cylinder information into our code to make it look extra cool, so we can see whether our bigger cylinder cars and do they have the same types of displacement on the highway and the city, and we can try that. So let's go back to this, and we'll go ahead and just add. Where can we put this here? I'm going to go to what I'm going to copy this, so I can, so if anything bad happens, I can get it back. But I'm going to put down here y after my y here. I'm going to put size is equal to CYL, which is my piece of data. And because I'm lazy, I'm going to copy that, and I'm going to go back to, hopefully you can see where I'm actually writing this, right there. Now, if I run this again, there we go. So now you have the cylinders, and you can see that in general, heavy or larger cylinder cars tend to be more heavy. One more note on this plot. Notice that the colors I've chosen, blue and red, not red and green. I know that we want to think green is a good color. Why not? People like green. Green's a satisfying color. But actually, though, think in terms of color blindness, because there are many people out there who have color blindness. And so I think that when you're doing plots, maybe blue and red are good colors. You might find that maybe red and black would be good colors. Who knows? It's up to you. But still, avoid using red and green, because that's if you can. Otherwise, if you can't, then that's okay. Okay, so now what I want to do now is, in my plot, I have a bunch of points. There's a lot of things going on here, and I'm getting kind of confused here. And it's getting late in the morning here. It's almost lunchtime, and my brain just isn't what it used to be. And so I need something that's helping me to guide my thinking through this. And so you'll see that there's another piece of information here. Whereabouts is that? Color blue, size rather, geom smooth. I have this piece of code right here, geom smooth. This is slightly different. This geom smooth is a line. In technical terms, this line is actually linear regression. You're taking these points, you're dumping them into a model, and you're figuring out if you were to take all the points and convert them into a line, and then the line would somehow represent where the points are. We'll discuss this all later on, but it's a model. And so the line is actually now you could replace the points. And so you could look at the lines, and the lines would be describing how the behavior of the points. So I'm going to just, because I'm lazy again, I'm going to just copy this. I'm going to go back to here. Oops, where's my... Just lost my RStudio. Where are you? Okay. I'm going to go here, and I'll put this, hopefully you can see where I'm typing. I'm going to put this down here, and we're going to investigate what this line smooth is all about. So when you run this, it may take some time to run, but that's okay. The code in this case is looking at, here we have the geom smooth. We're actually looking at slightly different information here. So we have the points that we've had before, where we have the x and the y. The x is displacement, the y is the city or highway. And we have the size information, which we've seen before too. But the smooth line, though, is looking at where the x is displacement, the y is highway, the line type is DRV. So the DRV is the drive, front wheel, rear wheel, I guess. And so we're actually now able to incorporate even more information that we can get out of this plot. So here we have information about the drive. Is it four-wheel drive? Is it front wheel? Is it rear wheel? What kind of drive do we have for this? And in addition, we have the cycle and the points and everything else. But these lines themselves, though, if you actually look at these things, the lines themselves are, let's see if I can highlight this here. The lines themselves are still talking, they're still based upon the displacement for x and the highway for y. And so, again, technically what it's doing is it's taking those points and it's magically, I'll just say magically for now, but it's magically converting them into a single line. So actually, you don't need these points anymore. You could just look at the lines and get an idea about how the trends are moving. Now, the thing about lines, though, is you might think, well, why would I even bother having a graph with all this stuff, and why would I care about having these, all these other points showing up here? And it's true, you don't need to have all those points, and the lines could be sufficient just by themselves. But the lines will not tell you anything about exactly where the points are, or it just tells you what the trend of the points is. If you made a line where you went through, you skewered every if you think of the points as a kind of a big cloud here, and you just skewer the cloud equally through the middle, that's where your line would be. But I'm looking at the upper left here, just above 40. Those are perhaps outliers, where x is equal to 2 and y is equal to maybe 42. Those could be considered outliers. Maybe that's faulty data, or maybe that's exceptional data, who knows. But we don't see in our line anything to do with those 2 points. And so you don't get the whole story when you look at lines. And so I guess the moral of the story here is that when you're looking at lines, you are actually trimming out, you're trimming out some of your data. You're trimming out something that you could have otherwise learned something from. It's actually quite dangerous to look at your data in just line form, because then you don't see these maybe, I guess, what do you call conjugations of points. You may not see them. Well, another thing we do see in this thing here is we see these gray, somebody said they look like French horns, like the end of this French horn, a gray French horn. Those are your confidence intervals. That's really saying that how confident are you that your points are actually falling inside those zones. And so you can think of this in terms of that if you had more data, then this model would suggest that based upon the trends we have found, if you had more data that fits, like for instance in the x equals 2 and y equals 30, the gray zone is very, very narrow. So more data would suggest that we'd expect those points to actually fit inside that grayed out zone. However, where x is equal to 5 and y is equal to 25, I guess, that's where we have this French horn-shaped grayed out area. What that's saying is that if we had more points, we really don't have such precision to know where those points would fall. Somewhere inside that zone, but we're not sure exactly where it is. And that's a function of the amount of, the amount of how grouped together, or how clustered, you could say, how closely packed in together those points are. So where these French horns are, I'll call them the French horns, the points are few and they are scattered out in different areas. Whereas where we have x equals 2 and y is equal to 35, the points are very kind of clustered together. They're tightly packed in that area. And so the analysis for those points would say, well, if I had more points, then they'd probably show up in that tightly packed gray area. But for x equals 4.5, or even x equals 5, and y is equal to 25, I wish I could point to these things, but I can't really point to them. But where that area is, there's just not enough information to suggest that the points are tightly packed together. And so if we had more information, it could be anywhere inside this area. So there's a lot of, so in short, in the x equals 5 comparison to the x equals 2 zones, it's a lot more certain where the points are going to land if you had more data for x equals 2 than if you had data for x equals 5. We will talk more about this when we actually hit regression. Linear regression is a fascinating, absolutely fascinating area. And it's surprising that when I think back to all the theory that goes into this thing, I'm surprised that back in the 1800s when it was first, when it was first developed, I guess you could say, that they were able to come up with as many findings as they did, knowing that every point had to be calculated by hand. But here we just have a computer that does this for us, which makes everything so much easier. if there's any questions, go ahead and stop me and just blurt them out and let me know, and I'll be glad to help. So this is so in the next image here, we have these 95% confidence level or confidence level intervals. And so these are like where how certain am I that predictions would be, that new points would be predicted to be in this area. Oh, this is cool. We've gone through this before in the coronavirus data analysis that we looked at. We used this library, Plotly. So I'm hoping that you already have this installed, but you'll notice that in the code that I give you, I'll have this install.packages, which has been commented out. And what that means is that I'm assuming that you've already installed this library in your toolbox. But if you haven't, you can still run this. Let me just show you how this thing works. I'm going to just copy this code as it is. And I'm thinking that I'm going to have to format things because it's probably not going to work the way I want it to work. So let me just give me a moment here. Yeah, everything just kind of comes together in one big mess. Goodness gracious. Okay, so what I'm going to do is I'm going to go ahead and I have my reference. I've got these p's equal. There's that one here if you can see this. Okay, I think that's what the code should look like. Yep. So if you were, let me just show you something here. If you were to run this line here, library plotly, you're trying to run this, you push the run button, you have your cursor right there, you push the run button, and you run it. And if you see some kind of an error message that comes in down here, something to the effect that your library has not been installed, what then? Well, then you find this line above that'll put in your code, where you just select it, and then you click on run, and then what it's going to do is it's going to install. I cancel it, but it's going to install your package. This is actually very important. You want to have that. You want to have this. You need to install this package for you to use it, but you only install it once, and then next, after you've installed the package, then you have to go back to the same this library line here, and then run this again, and then that will actually incorporate the code from library plotly into the code from that RStudio can use, and then we should be able to run the rest of these things here. Now I'm going to go ahead and run this. This is actually a very similar twist in, I guess I twisted the side twist, but it's a very similar code to what we've seen already for Ggplot. What we're doing now is, again, we're establishing a canvas. We're establishing the code. And this is a bit different here. We don't have to have that mapping function anymore, but we just have this aesthetics function just built in here as a parameter to this Ggplot function. So this is actually another parameter again. And what this thing does is it figures out the displacement is X, the highway is Y, and then it's going to use this color city here to highlight some of the data points. And so if I go ahead and run this, you'll see that I'm hoping that everything works okay. You have noticed that in your global environment on the right-hand side above, you have this new variable called P. I just chose P because P could be plot or whatever it may be. But remember though that this is actually now a variable, and so if I overwrite this variable, then that any code that needs that variable is not going to be able to run. And so if you are doing a whole bunch of different plots here, you may decide, for instance, to call not just P, call the plot not just P, but you might call it like P highway, something like that. Maybe I'll do that here just to make a point here. So I'm changing my variables, and you'll see that when I run this again, my new variable now shows up. P is still there, and here's what I wanted to show you, is that since now I've changed my variables, these are all new, and then I'm trying to plot my function with P, P is not recognized because my variables have changed. And it's for this reason that you want to have your code in these files here so that you can go back and see what's going on. Now, you probably think, well, I'll just push my up arrow on my keyboard and get back to my history. And while you can do that, that's actually a headache waiting to happen. It's just, it'll drive you absolutely insane. So please don't do that. So I'm going to run this with my P highway, and when I run this, you'll see that you get this beautiful plot here. And hopefully I can make this a bit bigger. Hopefully you're using this on your own machine. You can see this. But one thing I really do like is that you can now interact with your plot. I can put my mouse over different points, and I can see exactly what the displacement value was, and the highway value, and the city value. One thing that's kind of a bummer about when you use this plotting technique is that if you're printing your plots, it means nothing. You can't interact. It's only when these are like plots that are online or when people have them on their screen in front of them. But here we've incorporated color. You can see that the city has something to do with how much mileage in the city there's as the colors get lighter, for instance, you have better mileage. And so you can see that the colors down are here. This is the lightest blue I can find. I guess you call it the cerulean blue. This is your displacement of 1.9, whereas the darkest color I can find, maybe it's here. It's here. This displacement is 7.0, and that's the darkest color that you can see. One thing I do like, though, is, I don't know if you can see this, but where my mouse is in the top of these two, like what looks to be like an equal sign, click on that. And then as you move your mouse through this, seemingly for that same x-axis, you have other points. And you can compare those points as you just mouse over. And so it gets kind of complicated after a while. It's kind of hard to see what's going on. Here we are actually comparing the points that I'm looking at with the line beneath it. And underneath that, there's another, I'm looking at the highway point with the city point, and then the line. And so you get a lot of information here, but one thing that you might think is that it's just cluttering my view here, and I can't see everything. So you can always like turn that off, and then just go back to, oops, how do I turn that off? Go away. You can always turn, or you have to click the other one here. And then you can just click on individual points here. You can also click on zoom in, so you can actually zoom in and see things. I think you have to use the pan button here to actually move around and see pieces of your plot. But actually, though, you do have the ability now to do some quite sophisticated analysis by actually kind of getting inside your plot and looking up close at your data. Now, if you're moving things around and you decide that you want to zoom out again and go back to the way things were, click on the home. It's like a little house here. Click on that, and that takes you back to the default view of your plot. And so Plotly actually makes everything much, much easier. But remember, though, keep in mind that if this is for publication where you're going to be printing everything out, it doesn't really, you can't use any of this. If it's on paper, you can't use this functionality, which is kind of too bad. Oh, one more thing I should talk about, though, is you have download plot as PNG. If you click on that little camera, you can actually take a picture, and although you can't see it on the screen here, I can actually save the file somewhere. And I think it calls it, my computer is calling it new plot, and it seems to be doing a pretty good job. In fact, I can show you what the plot looks like. Let me just get back to my slides. Bear with me for a second. I just locate it, and I'll drag it into drag it up here. And so this is what I get. And so that's the plot that you'll see when you do this. It seems like it's a bit blurry in some cases here, but I think it prints okay. And so if you're using it, and you can still use this for your publications if you're interested. Anyway, so now you have this functionality, and this is actually quite nice because you're probably thinking, well, is it really so cool to be able to print stuff up on or to make files of my work? I can say, yes, it is, because that means that it saved you having to write the code to actually make that screenshot. I guess you can always use your own computer to make a screenshot, but you may want to automate the process of making screenshots in some way so that you're not just, you don't have to actually drag over your screen, but you can actually have some kind of a system of making screenshots here. And so this could be part of your system of actually collecting your graphs, or maybe if you wanted to actually collect all the graphs from all the work that you're doing, then you might want to just write some other code to actually save those points. But if you're just looking for a quick and easy way of making a download of or downloading your plot, this is your way. But please, 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 always, always, always remember to keep your code here, because what's happened to me is that I've created some plots that I've just fallen in love with, and I'm just thinking, oh, this plot is just beautiful. Ah, and then I think, how did I make this plot actually? How did I put this plot together? And then I can't remember how I did it, and that's just a nightmare. It's something It's like you've met the love of your life, and then you realize you'll never see this person ever again, and it's just terrible. So you want to be able to kind of hold on to your code so that you can recreate that moment here of this infatuation with this plot. But I mean, what I'm trying to say is, hold on to your code because you'll need it. You'll need that code again when next you're trying to make that same plot. If you change the data, if you have similar kinds of data, and you want the same plot, the same kind of look for the plot, then you could use that data again. But hold on to that data because it's going to be so essential. Yeah, so again, these Plotly things they come up. In fact, this plot that you see on your screen, I actually made using Plotly. I just used that little camera to make an image, and it looks okay. I'm looking to see whether it's, sometimes when you use these functionalities in some softwares, everything comes out looking kind of hazy or blurry, or the colors aren't the same, but this looks okay. I think this is probably about the same here. Oh, is it the same? Oh, so the next plot here from Plotly is to use sizing, and so that might be more handy. And so we can just, I'll try this too and see what happens. Now notice that this is going to overwrite any variables that I have that are called P in my system here, and so you want to make sure that you're well aware of that. So now I have to reorganize everything, which is just cray. There we go. I'm going to just call this PCTY. I can see that it's city because, well, actually there's city there. Maybe I'll call it, well, I guess I'll call it city for now though. No, I'll just leave it. Let's leave it the way it is. Save me having to go through and edit all this stuff here. I'm going to run everything here, and then when I see this plot coming up, you'll see that you get this lovely looking thing here. And so again, you get the line, you can get the city mileage here, but you also get the sizings, and so perhaps that's easier to get some ideas on. You can use this for your analysis. And then if you run your cursor over the line itself, this is actually kind of interesting because it actually tells you the color. You see that third line down, city, then you have this hashtag 3366FF. That's the particular color that your line is using to be drawn. It's interesting. I don't know why. I know. I just wondered why would you need to know that? But I guess that's just one of the things that they. I mean, I could see how you could put that, how having that as an option that you could turn on would be important, but I don't see why they'd have that as a default option. Exciting. Okay. Let's go to the book here and get some and start doing some work in here. It's we have 25 minutes here, and so I wanted to kind of move forward. Now, again, whenever I have slides that come from the book, there'll be no surprises. I'm always going to give you a slide that looks like this, where you can see that if you have, by this book, I mean the printed book. If you have a printed copy of the book, then you're on chapter 3. But for some strange reason, if you're using the web, they don't have the same chapters, and so it's chapter 5. And by the way, this is the link that you can use to get to that chapter. But these are all about what they call transformations, where you're taking data and you're moving it from the raw data that you get. When you download data online, it's basically just a mess. It's like this bookstore where if I'm looking to read I don't know, Tennyson's poetry or whatever, if I want to read some specific book, I have to find that book in this mess. If I want to do a specific exam or a specific study of certain data, then I have to find that specific data in a mess of other data. And so we're talking about what's called transformation, where you're actually extracting particular pieces of information from a data set that you're going to study. Because typically when you download data sets, you have so much information there. I mean, they don't know, the suppliers of the data, they don't know what you're going to be using the data for. They don't know whether you're going to be studying this or that or the next thing. And so they just give you everything. And so in this case, a bookstore owner doesn't know what kinds of books you're actually going to be reading. So they just give you a whole selection of all books. And then you just have to choose the book that you want. And in data, you have to choose the data that you want, the actual subset of data. And you would do this because some of these data sets are just absolutely enormous. And so you probably wouldn't want to have the whole data set floating around in the memory of your computer because you might run out of memory. And so you might just want a specific piece of information. So we use what's called filters. Now this is a coffee filter here, but let's think about what the coffee filter is doing. When you put coffee into a coffee filter, you pour hot water onto that coffee filter with the coffee in it, and coffee comes out. A liquid form of coffee comes out. But you don't really want the coffee grounds in your drink, because that just makes it difficult and gets stuck in your teeth, but that's really not the coffee drinking experience. The grounds are to be separated from the liquid. The solid is to be separated from the liquid so that you can actually enjoy your cup of coffee. And so that's a filter system here. Now, we're going to do the same thing when we filter information out of a database to use to run our analysis. And they call that in data science transforming your data, some kind of transformation. But what it means in this case, excuse me, is what we're doing is that we're taking out information and we are going to change it into a way that we can actually manipulate. It seems that it's very rare to get data that easily works with analysis. You have to, first of all, transform this data into something that you can work with. So data transformation, I'm looking down here, data transformation is the process of converting data or information from one format to another. And you're probably thinking, well, how hard could that be, just converting the format of data from one thing to another, or from one format to another? It actually can take a lot of time. In fact, you'll notice that as you're going through your analyses, that most of the work that you do, most of the time that you spend is probably 80% of your time is going to be spent actually transforming your data or getting things in order, and then the last 20% of that time is actually pushing run where you get some plot that comes out. Now, nice thing for us is that the data sets that come incorporated in our studio have already been transformed for us. And so everything's neat, everything's organized, the columns are all filled with information which is related in some way. So we have this, so everything's been done for us. But that doesn't happen when in the wild, when you download data, when you get your own data. Sometimes you have to transform the data yourself so you can actually focus on specific things that you want to focus on. Now, let me just go ahead and show you something here. We're going to go after a new data set, and I'm assuming that nobody here has installed this package just yet, so we'll do this all of us together. So again, we have this install packages. This data set, NYC Flights 13, go ahead and put this into our studio here. But this data set is it's the information. If it asks you to reset your R, just go ahead and say yes. Why not? Just give it to it. And that'll be fine, just as restarting the R session. You'll lose your global environmental variables. Well, I guess they come back in this one. But sometimes they go away. That's okay. In fact, what I'm going to do is I'm going to do an rm list is equal to ls. If I type in this code here, then I'm going to lose my variables, and I'm going to click on my little broom on my plots, and then it makes all my plots go away. And so really, I'm working with a fresh version of my our studio here. There's nothing in memory here. Now that I've just run this thing here, I'm going to put this hashtag in front of it, and that comments the whole thing out so that I don't run this again. But if I'm using a different machine, or maybe a machine that doesn't have, or maybe an install on my machine that doesn't have this particular library ready to go, then I can get this code back. So don't remove this code, but just rather leave it there so that you can actually download that code again if you need it. Now going here, I need to load up my libraries, and the library for this New York City flights information is called NYC Flights 13. I don't know why they call it 13. I don't know whether there's any. That's like year 13. I don't know. Could be. So I'm going to go ahead and just dump all this in there. Whoops. You want each of these things on its own line. And so when I run my libraries, tidyverse, of course, everything works fine for tidyverse. I get this information here. If you're using a Docker container, I think the tidyverse, I don't think you have to install that, but I think you still have to install every other library that we're using here. So, but you can always just go ahead and just install these libraries. So now let's just go ahead and use this library for something here. Let's just see what's actually in this code. I'm going to minimize this. If I go back to my slides, I think you'll see that here we are. We have this command here called view flight. I think that view flight should work if it, well, let's just, get back here. Okay, I'm going to type in this view flights, and this is going to give me a listing of the information that's in my data set here. Now, whenever you have a new data set, it's always, I would say, very rewarding to spend time analyzing looking at the columns to see what kind of data you have. Because remember, this is going to tell you what you can do with the data. What kinds of questions can you actually ask? So here we have the year, we have month, the day, the departure time. I'll give you an overview here. This data concerns all flights that take off and land all over the continental United States. When they take off, when they're taking off, if they take off on time, the actual scheduled time that they have, and the actual time and the time that they actually do take off. So the scheduled time versus the time that they take off if they were delayed or they take off early. So we have that kind of information here. It's the timing information here. We also have information here. Okay, so that's the month, the day, the year. This is for 2013. That's right. The month is for that's January. The day is the 1st. The departure time. This is like 5:17 a.m. I think you can move all the way up to the end of the day here, but I think it's like for a 24-hour. Yeah, I think it's like a 24-hour clock here. That's okay. Then we have the scheduled. We have the departure time. That's what the time is that they say the travel agency sees on their screens, or the flight agency says the flight's going to be taking off. But then we have the scheduled department, the departure time. That's the time when they actually do take off. But the scheduled departure time is when they have to take off by their own paperwork. So in this case, I see I see 700 here. That's probably 7 in the morning, perhaps. Where they said that this flight has to leave at 7 in the morning, but then they realized at 6:59 that everybody was there, all systems go. Let's go ahead and just take off now. And then over here we have this departure delay, which is -1. This departure delay is the difference between these two numbers, departure time and the scheduled departure time. And so you'll see that if you subtract 700 from 700 700 from 701 in the line below, you'll see the number is 1. So, okay, you're probably thinking, why would they have that column there? I don't need that column. I could calculate that column with my own code. That is what they call redundancy in data. Now you might, as you're putting your data set together, you might elect to remove this column here because you don't need to subtract 709 from 700 right below here to determine this number here. In fact, you could just, you don't need this number here. You could just make the subtraction and figure it out. And so that means you could save this memory, if you will, and not have to worry about this thing here. But it's here just for the time being. Here we have the arrival time. This is what time the plane actually arrived, and this is what the scheduled arrival time is, what time the plane was supposed to arrive in the destination. And again, we have this delay, and that's again the difference between these two numbers, arrival time and the scheduled arrival time. So here we have arrival time for, oops, I keep moving around here, 10:27 and 10:25. The difference is 2. So you can get that, you see that how that's going out. Then we have the carrier information here. We can see what flight that, I guess that was what the flight was. Then we have the flight number. We have each plane has a serial number, which is a tail number. So we have that. We have the origin. That's where the flight was coming from, and then we have the information about where the flight was going. LAX, which is LA. Then we have the arrival time. We have the distance it traveled. And we have the hour that it, I guess, arrived, and then we have the date that it arrived, and the time here. So really, this data set is quite nice though because it has all types of data set types in here. It has numbers, dates, it has strings. It seems to have everything here. But in all the things that we just discussed here, you have to think about the kinds of questions now that you can ask of this data set. So in other words, supposing someone offers you like a huge amount of money to do some kind of analysis, and the analysis question that they want to know is, what was the most preferred in-flight drink from all of these flights? They say, well, you have data. Go ahead and answer the question. And you think, well, okay, but I can't answer that question about the in-flight drink because there's no column of information that concerns in-flight drinks. And they'll say, but you have all this data. Just go after it. Stop lagging and tell me what the... Was it Coke? Was it Sprite? Was it tomato juice? What was the drink? And you would say, there's no way I can answer that question. This is a common problem that you will have as a data scientist as you go through your careers, and that somebody who doesn't know what the data is about will give you a bunch of data and they'll say, go ahead and tell me what was the captain of this flight thinking when they took off? I need to know that. And you'll think, there is no way I can tell you that because that is not in the data. There's no way I can actually mention that. There's no way I can even study that from this data. This is actually a personal thing for me because when I was doing my doctorate, I was working in a bioinformatics lab where we worked with biological data and try to figure out about how proteins interact with other proteins. It's called protein interactions. Protein-protein interaction was actually a very complicated area. We have all these different proteins, and you're trying to use numbers to figure out how one protein will somehow connect or bond with another protein. And we had these people who'd come in who were medical doctors, but they weren't researchers, and they didn't know how research was done with data. And so they'd come in, they'd say, "Oh, so I have some data for you, and what I want to do is I want to find out whether these proteins, what color they were." And we'd say, "Well, actually, they actually weren't asking what color they were, but something similar." But that was not in the data that they gave us. And so we'd say, "I'm sorry, we can't answer that question." And some of these guys would get so upset with us. They'd be like just yelling, and they're like kind of spitting as they're speaking, because they're saying, "Well, what do you mean you can't tell me that? You have all this data. Surely you can figure that out." And said, "Well, no, because that information is outside of the scope of this data." And so there is a scope of data that you have to recognize because that will inform what kinds of questions you can actually go after. Anyway, so this is the next slide here. What is the data? You have to spend some time actually to go through and figure out where the questions end. Like what questions are you not allowed to ask here? Now you can get an idea about this is some code here. I'm not going to bother typing this in just in the interest of time. But we've already typed in this view command here. Notice the capital V, and flights is actually what this data set is called. Now I have this other thing here called names, open and close parentheses, and names will tell us the column headers. So you can look at the names here, and that should give you an idea about the kinds of questions that you can ask. There are no column headers that talk about food or drinks or the thoughts of the captain while the flight was in session. So that means that those questions are necessarily barred from this analysis. You cannot ask those questions here. So yeah, this is more inspection information. As you're looking at the data, that's actually called inspection. You want to spend some time to really look at this information that the data has to kind of determine what you can do with it. But here we have flight numbers, dates, schedules of departure and arrival times, the actual departure and arrival times, the carrier, airports, distance that they flew, all this information here. So those are the kinds of questions that we can actually ask. Now, I wanted to spend some time, before we get to the analysis part, I wanted to spend some time talking about these things right here. So let's go back to our RStudio for just a moment. Here we are. I'm looking at the flights. Now, I'm looking at my flight data, and I have just a constant barrage of information. Now, supposing I wanted just to pick out a specific column or a specific row and just look at that information. Well, we can do that. So, for instance, if I type in flights, open and close parentheses, and I have 1 comma, this is going to give me, let's put this up here. This is going to give me the top row here. So when you're working with flights here, or sorry, when you're working with a spreadsheet type data here, if you have the square bracket, the first piece of information you put inside the square bracket is going to be rows, and the second piece of information you put in the square bracket is going to concern columns. So if I put in, for instance, 1 and comma and leave columns blank, that's a kind of a wild card. You don't actually, a lot of people would think, well, shouldn't I be putting something like that in there? No. If you put that in there, that's not going to work. It's going to give you an error. You just leave it blank, and that's how you get this thing. But notice though that, for instance, the this 1 comma gives me the top row, so I can see that this information here, 2013 11517. This is actually the top information that I see in my first row. And so that's how you can actually pull out this information. Now, if I wanted to have the first 2 rows, this is kind of looking weird. But you have this colon between these things here, and that says, give me everything from 1 to 2, or I can say, give me everything from 1 to 20. And so this is like a sequence. Now, I don't blame you for not liking what you're seeing so far. When you look at your code, you think, how could that possibly make any sense to me? You just have to memorize that and just say, okay, well, it's going to be this way for every time I want to use, every time I want to like actually pull out information here, I just have to use this format. It's just one of the accents that happens inside this language. But once you get used to this, it works out much, much better. Now, let's say that I want to go after columns 1. That's just 1. I can actually pull up column 1 here, which you'll see is the year column. In fact, if I go to the very top here, you'll see that it says year. So now I can actually pull out the column year. Let's say I want to pull out columns 1 through 3. What are those columns? I have year, month, and day, and that's exactly what I have, year, month, and day. So you have this ability now to kind of go after specific cells. One thing I will say, though, that is you can put them both together here. So let's say that I want to have the first row and I want the first column piece of information. What that really translates to is this value up here, 2013. It's now it's the cross product between these two. So the reason why we're going through this is because when you are actually pulling out data from data frames like this to make your own data frame for your work, then you may need to go after specific pieces of information, like specific columns or rows or something inside all this information up here. And when you go through how do you actually pull out that information? You do something like this. So let's say I want to have, I don't know, let's say I want to have the first and second row, and I want the first and, how about I want the departure times here. So that's going to be 1, 2, 3, 4. So that's the fourth column along. Oops. And so now I can go for, I can see for the first and second row, which is 1 and 2, looking at column 4, which is the year, month, day, departure time, you can see that it's returning the values 517 and 533. And so that's how I can actually isolate those particular values. Go ahead and try something here. I mean, just try pulling out, let's say we want the carrier information. So what number is that in my column? So that's going to be the years 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So carrier is the 10th column in my set, UA. There we go. Let's say I want to have the first 20 carriers. I can do this. So now you have this new power in your hands where you can actually pull out specific pieces of information. But that isn't everything that we can do. We actually have much, much more that we're going to be doing with our data set here. But remember, though, that you do have this ability. You can use a vector going down to the bottom here. This is more or less kind of the same idea. Maybe let's go ahead and pull this out and show you what that looks like when you run it. But if I run it like this, I hate this. Actually, I'll tell you, it's taken me many years of therapy to be able to say this, but I hate this function here. C open and close parentheses. I like how it works, but I really dislike the name. This creates a vector between 1 and or a vector where 1 and 5 are the central pieces. So, for instance, if I put C, 1, and 5 down here, you'll see it's an array. It's an array. In fact, I can even do a type of and see what this thing is. It's a double. It's an array, but basically it's filled with a double here. So what it's doing is it's thinking of 1 and 5 as separate pieces of information in an array. But they call it in R a vector. I don't know why they didn't call it V for vector, open and close parentheses. But C, are you feeling this here? No? Okay, hold on. Maybe I'm just kidding. Maybe I've been looking at this stuff for too long here. I don't know. But anyway, but that's what it does. It creates a vector here of elements 1 and 5, and you'd use that to define your specific columns. So getting back to this thing. So why am I showing you this? So going back to this over here. So let's say I want to see columns 1, 3, and 5. Well, there we go. So what is 1, 3, and 5? That's year, that's day, and scheduled departure time. Year is column 1, day is column 3, and the scheduled departure time is 5. And so you'd use code like this to create that, to actually cherry pick the columns you want. And I can do the other side too. Well, I'll say C, give me rows 1, 8, and actually no, maybe that's too far down. I'll try and see it here. 3 and 5, something, or actually 3 and 6, 4 and 6. So there we go. I can actually. So these are the actual pieces of information that I can actually pull out with some, with a one piece of code. Now, this is actually kind of cool because I could always take this information that I've just pulled out and I can set it equal to my data and then do this. My dat, you'll see that my global variable has just opened up. I have some information that's just appeared up here. And now I have my own data. So I've just isolated some data that I can use. Now, it may not work in your code just yet. We have to discuss how to convert it so that it'll work, but I think that it should work in most cases here. But if you wanted to like do some sophisticated plots, then you have to convert this into a data frame so that it can actually be, well, we'll talk about that later. Okay, so let's get back to the slides here. We have like 3 minutes left, and I think that's, goodness gracious. We've just talked about all this. Okay, this is another nice thing we should talk about. So flights, if I have flights, open and close brackets, 1, comma, as we saw before, this shows you not just the names of the columns here, but it also makes an effort to show you the type of information that you see down here. So you can see that under the year, in the slides here, you can also try this command if you want, but under the year, you see int, month you see int, day you see int, and departure time you see int. These are because these are numbers. The data has been put together with numbers. If you had, for instance, some characters or some kind of a string, it would say CHR, as it would do. And in fact, you can see here, 10 or more variables. Carrier is called the CHR. Carrier is a string. I should tell you something. When you run this command here, flight, open close bracket, 1, comma, it just shows you what your screen can hold, but it doesn't show you everything here. So it doesn't inundate you with information, but it does show you things. And so if I go back to this, let me see what my screen will show. Let's see if I go to flights. Whoops. Let's type this in, I guess. Flights, 1, comma. So when I do that here, you can see that it's making an effort to show me what kind of data this is. Now, that will inform us later on when we're working with, say, if we're working with plots, we couldn't use carrier as our plotting piece here because a plot only works with numbers. These are carriers. The carrier information is actually encoded in text, and so you couldn't plot text. And so that means that this will help you to figure out how you can plot some of your data, or how you approach the analysis with your data based upon what kind of data type it is. Anyway, more on that as we go, but I just wanted to give you this next slide here, which is like talking about how you can understand what the numbers are, what the types are they're telling you. INT stands for integers, double, then we have the character, and then DT, TM, that's a date and time. You can actually create data that's actually just time data, and then we'll talk about that, but it's actually quite important because then it makes it much easier to write code if everyone has the same date and time format. More on that later. We have logical, that's like booleans. And then we have factors. These are more like, I guess, arrays of how many different types of classes there are in your data. And then we have dates. Each of these we'll discuss. I think that I'm going to break here. When we come back on Tuesday, we're going to talk about these basics, these functions right here. This is where we're going to actually start being able to get some smart. We can use some smart code here to actually pull out not just all information as we've been doing before, but actually pulling out specific types of information which concern some special, they have their requirements. So for instance, we can actually like pull out information where information is greater than a certain number or less than a certain number, and so we'd use these functions to do that. So I'll have to let it go have to let it rest here, but when we come back on Tuesday, we'll go through these same 5 functions here, and I think you'll find that these are actually quite exciting.